Now let us go back to the first question. In experiment 1, at which temperature, not 45 degrees Celsius, does the rate of reactions appear to be incorrect? So let's go to the graph, first graph. And we'll realize that this point is out. It is not aligned with the curve. We do not refer to the point at 45 degrees Celsius, so we don't refer to this. This is the point that is out. Now, this is the point at which temperature at 20 degrees Celsius. So what we can do is we circle this out and put part B. And that is our answer at 20 degrees Celsius. The point at 20 degrees Celsius is incorrect. This point. Next, use the graph to find the rates of reaction. It's actually referring to the rates of reaction at 23 degrees Celsius. So let's highlight this for experiment 2. Now make sure it's referring to experiment 2. So we look at curve number 2 instead now. So we look at curve number 2 because it's referring to experiment 2 at 23 degrees Celsius. At 23 degrees Celsius. Now what do we do? For a question like this, you need to draw a line on the graph. So at 23 degrees Celsius, 23, 20, 22, 21, 22, 23. So 23 here, I will draw a straight line all the way to hit my second curve. I'm going to use a red marker so that you can see more clearly. So once I hit 23 degrees Celsius and I draw a line all the way up to hit curve number 2 at 23 degrees Celsius. And once I hit the curve, I'll draw a horizontal line to find out my answer. It's at 60. That shows that at 23 degrees Celsius, my rate of reaction per minute is 60. So that's my answer for part C. I write C over here. So let's go back to the question. So the rate will be 60 per minute, and that is how I get my 1 mark. Next question. What is the optimum temperature of the enzyme? Now what is optimum? Optimum refers to the best temperature, but for this case it's for the best reaction rate temperature for the enzyme. You may want to write this down on your question paper so you can remember. It's referring to the best temperature where the reaction rate takes place. Now let's look at the graph. Reaction takes place when the temperature increases. Reaction increases as the temperature increases. And it's at the best, or what you call the optimum rate of reaction at this temperature, 40. For the second curve, where the enzymes are doubled, that means double amount of enzyme, is here. The temperature is also 40. So what do? I will indicate here. This is the point where is the when the enzymes are most active. You may like to write this down. That's for my second curve, and this is the enzyme are most active. Write this down on your graph so that you can remember. So these are the 2 points where my enzymes are most active. So the temperature is at 40 degrees Celsius. See that? And it happens to be the same for both curves. 40 degrees Celsius is the temperature where my enzymes are most active. That's my answer for part D. Therefore, what is the optimum temperature for the enzyme? 40 degrees Celsius. You may like to write down this sentence to help you to understand better. The enzymes are most active at 40 degrees Celsius. That will help you to understand better on this question. Last question. State how, underline, doubling the concentration of enzyme affects the rate of reaction using the graphs drawn. Now, looking at the graph, first curve have a certain amount of enzyme. The second curve is when the amount of enzyme doubles. That means the amount of enzyme they increase twice. They use twice the amount. Now, look at the rate of reaction and compare. How much has it increased with the same temperature? What you can do is you can also refer to the points. For example, at 5 degrees Celsius, instead of 4 reactions per minute, it has increased to 9 reactions per minute from here to here, from here to here. At 10 degrees Celsius, the reaction increased from 9 to 18, from here to here. At 15 degrees Celsius, it has increased from 15 to 33, from here to here. So what is saying that the graph tells us that when you double the enzyme, the rate of reactions has increased more than the double time of reaction. So what we can write here is states how doubling the concentration of enzyme affects the rate of reaction. So we answer this question by writing the rate of reaction increase or decrease? Increases more than how many times? More than 2 times, more than twice, more than 2 times. When the concentration of enzyme is double. So how do you score for the 1 mark? The keyword will be increases more than 2 times. So from the graph, it tells you that the reaction time, the rate of reaction increases more than twice, more than double, when the concentration, the amount of enzyme is doubled. Instead of putting in, for example, 1 cm³ of enzyme, I increase the concentration to 2 cm³ of enzyme. It reacted faster. And here you go. Here's my final answer.